So here we are back again, taking derivatives of really simple things, but now it's a little different because the variables are different. I'm trying to take the derivative with respect to x. That doesn't match up with this variable. I'll show you what I mean exactly in a moment, but think of this right now as the chain rule. I'm taking the derivative of 5 times something, and I take that, and it's just 5. But what's the derivative of that inside function? What's the derivative of just y? Dy dx, that's what I tell you. That's what I tell you it is. So when I take the derivative of this, sure, it's going to be 10y to the first. But if these variables don't match, this chain rule problem, don't forget to multiply by the derivative of the inside function, the y. Don't forget to multiply by the derivative of y. Same thing's going to happen down here. The derivative part is easy, but you have to remember, if that doesn't match up, the derivative of z itself is dz dx. So, time out. Why didn't we do that before? Well, we could have. Over here, taking these derivatives, we said that was 5. Could we have taken a moment to write the derivative of x? Sure, we could do that. The question is, why would we? Why would you write dx over dx? Isn't that just equal to 1? And the very next derivative here, it is true, that is 10x times dx over dx. But why write dx over dx when that equals 1? 20x cubed, sure, you can write dx over dx, but why bother? It's equal to 1. So when the variables match up, I'm taking the derivative with respect to x of a variable that's x. You don't need to bother writing down that extra little portion, but when the variables don't match up, you do need to remember to put down that extra little derivative symbol, the dy over dx, the derivative of the inside part, the derivative of y, or the derivative of z. Which brings us to our last problem. It's actually kind of a preview of what's coming up in the next lesson, but little Pythagorean theorem there? What do you think that is? Yeah, you're almost ready for the next lesson, but I'll wait for that later. Just a little hint though, all you're going to do is take derivatives not with respect to x, but we're going to look at word problems and we're going to be taking the derivative with respect to time. We're often finding how things change over time. But right now, that's the trick for implicit differentiation. Examples, please. Here we go. Got some examples. So easy enough. I'm taking the derivative of these. Wow, the derivative of x squared. The derivative of y cubed. The derivative of 10. What's the one thing I forgot to do? What do you need to remember? Oh yeah, there's something about that y squared. Make sure if the variables aren't matching up, I take the derivative with respect to dx. Don't need to write anything here, but when I'm taking the derivative of y, I do. And now, the only thing you have is a little bit of algebra. So, move everything that doesn't have a dy dx onto one side, and then divide to solve. Now, does that look like a function? No, it's not a function. Who cares? There's lots of things that we model in life with non-functions, okay? So get that through your head. These don't have to be for functions. This is just an equation to begin with, all right? There might be circles, ellipses, other things that have non-function properties. Okay. Part B. There's one special rule that you're going to have to use here. It's not just the power rule. That's my hint. Watch the next video to see what to do with the last 2 examples there.